Okay, hi everyone. My name is Jawad Damir. I'll be talking about the security of microservices. Okay, and to be more specific, actually, I'm going to talk about the confidentiality issues of microservices because, like, the information security is composed of three main topics: confidentiality, integrity, and availability. Okay, so I'll be focusing on the confidentiality of microservices, or the confidentiality issues of microservices. Okay. So yeah, some facts about me. I'm Jordanian. Okay. Have anybody been to Jordan before? Yes. Okay. Good for you. I'll show you some pictures. I think you'll like it so much. I'm a CMU graduate. Meanwhile, I am a lecturer at Jordan University of Science and Technology, and I'm also the assistant director of Information Technology and Communications Center. Okay. And I'm the founder of Data Access Agility. It's a cloud tool that allows you to generate the data access code for software applications. So here's a picture from Jordan. This is Petra. Maybe you have seen it before. Okay. And here is Wadi Rum. It's a famous place, actually. OK, before I go into details, I'd like to give some introduction about the talk. So my talk will focus on three concepts: microservices, confidentiality, and insider threats. Okay? So my point is, microservices are less secure than monolithic services in terms of data confidentiality. This is the main point of my talk. So the question is now, why am I talking about this? Okay. So am I saying that because, OK, to avoid microservices? Of course not. Okay. So I'm saying that my goal is to build awareness of this problem, then to propose some solutions for the problems we will see. So this is our agenda. We will talk about the outsider and insider threats. Then we will talk about the enterprise data, types of enterprise data, master and transactional. Excuse me. Then we will move to the first major point of my talk, which is the microservices versus monolithic services. And finally, excuse me, finally, I will present some solutions for the problems we will see later on. So who are the outsiders? Outsiders are people who do not have access to our data. Okay? And they should not. They should not have access to our data. For example, the public, people, okay? The competitors of my business, okay? Foreign governments, especially if we are talking about the data of government agencies, then foreign governments will be the outsiders for my business. And actually, this is the first group I think about when I design a new system. So it's like when I design a new system, OK, how can I protect this system from the outsiders? So I always think about this group. Okay? Insiders are different. They are people who have access and should have access to my data. Okay? So they are employees, contractors, business partners, and it could be hacked accounts. Okay? Because all of these have access to my data. Actually, the threats caused by insiders could be intentional, which is the problem. Could be intentional. How? So maybe I can steal the data of my company to benefit a competitor. Okay? So this is a threat caused by insider. I have access to the company data, confidential data. I take it, I give it to somebody else, a company, just to benefit that party. So the question is now, who is more dangerous, outsiders or insiders? I'm not going to make a debate about this because there has been a long debate. What I like, the main point, just to agree that insiders are risky. It doesn't matter if they are less risky or more risky than outsiders, but they are, okay? They are risky and they are getting more popular, okay? So the insider threats are getting more popular, and finally, they are difficult to identify and prevent than outsider threats. Okay? There are so many surveys about the insider threats, okay? The numbers differ. For example, we have a survey here, the 2016 US State of Cybercrime Survey found that 27% of electronic crimes were suspected to be caused by insiders. Okay? If you search online, you will see so many surveys about insider threats. Some say, okay, it's 40%, 50, 30%. Okay, the percentage itself is not important. What's more important is that insiders are risky. That is the main point. So before I leave this section, just to make sure that we understand the point or the idea that insiders are risky, and we should not assume that insiders make an ideal use of my data. Okay? If we think so, I think we should change our minds. Otherwise, if incident happens, it could destroy the reputation of business. Okay? Okay, let's move on to the next section, the enterprise data. Actually, we have two types of enterprise data. We have the master data and the transactional data. So what's the master data? It's data about the business objects that participate in business processes. Okay? Such as, for example, for a hospital, we have the patient, we have the physician, we have a material, we have room. All of these objects participate in the business processes inside the hospital. So the master data is data about these objects. For example, the patient might have the full name, the social security number, the email and phone, and so on. So as we can see, like, the master data is not used by one department within the hospital. So if we think about the full name, do we use the full name in only one department in the hospital, or everybody needs this piece of data? Everybody, okay? So it's used by multiple business processes inside the business. And it is not, or they do not change so often. They might change, but not so often. For example, the email and phone. How often do we change our emails and phones? Okay? So these characteristics of master data makes the master data highly confidential. Highly confidential, because if we disclose the master data, then it will be so difficult to change this data for the business objects. For example, the social security number, the credit card information, once they are closed, it will be so difficult to change them for the patient. Transaction data is the other type of enterprise data. This type of data describes business events or business transactions. Okay? For example, a bank deposit. When we say amount of bank deposit, this is specific to this transaction. Okay? It's also composed, this is the situational data. It's also composed of data about the participating objects. For example, the customer ID or the patient ID. Okay? These are references to data that exist in the master data of the organization. Best practices. So most of my examples will be about a hospital, okay, because the healthcare data is usually highly confidential. So yeah, the best practices for enterprise data. We will have multiple applications, okay, and we will have one location or one database that has the master data. So it is recommended that each application has a database that stores the transactional data, okay? And the master data should be separate. It should not be within the same application. Why? To reduce redundancy and to improve consistency. For example, we don't have to store the date of birth in many places or the social security number or the phone and email, okay? It should be in one place, and these applications will reference this data from here. Okay, I'm done with two sections. The main point of these two sections, the first one is insider threats are risky. So we should not say, okay, our employees are safe. They cannot disclose our data. This is the main point. The second point is master data is highly confidential. Okay? Now let's move on to the next section, which talks about the service-oriented architecture. So or SOA, service-oriented architecture, allows us to develop the software as a set of services that are accessible over network, okay? And the same service will be accessible or used by multiple clients, such as mobile apps, web apps, TV apps, and so on. I'm not going to talk about the benefits of SOA, okay? But I'm going to focus on the difference between the monolithic architecture and the microservice architecture. So what's the difference? Monolithic services are usually big services. When I say big, that means different things. For example, the scope of the service is big, or the amount of business logic is also big, and so on. On the other hand, the microservice is usually small. So the scope of a microservice is limited. We will take some examples. Okay? Monolithic services handles complete business transactions from A to Z, whereas the microservices handles like single part or part of the business transaction. Okay? For example, when I click on the place order on Amazon, okay, if I implement this place order as monolithic service, this service will be responsible for payment processing, scheduling shipments, inventory control, and so on. If I design it using the microservices, no, I will have single service for shipping and one other for payment processing and the other for inventory control. That is the difference. And of course, because it handles a complete business transaction, it should have access to multiple data sources. Okay? Whereas the microservice usually has access to single data source. So let's take an example to explain the major point of this presentation. The example will be about a hospital information system. They have several applications in place, okay? Health record, patient master index, appointment management, billing, and so on, okay? And each one of these applications has its own database or database schema. When I say like database, it doesn't mean isolated database server. It could mean a schema inside the database. So each one of these applications have its own database, okay? And the patient master index here, this application or this system maintains the master data of patients that we have seen before. Now we will imagine we want to develop the appointment management, or one feature of the appointment management software. So this software or application is responsible for managing patients' appointments. Okay? We have something called appointment card. It's composed of the date and time of appointment, the reason for visit, the consultant name, the patient name, and the patient phone number. We will see now how to implement this appointment card using the monolithic architecture and using the microservice architecture, and we will see the difference in terms of data confidentiality. Okay? Okay. So if we decide to implement the appointment card using the monolithic architecture, we will have one service. Okay? It's called appointment service. And this service will talk to the appointment data. This has the transactional data. Okay? And it will talk also to the patient master data. So after we get the appointment, we see the patient ID. And based on that ID, we can fetch the data of the patient. So we return a full response that's composed of date and time, reason for visit, patient name, and patient phone number. Okay? Because the patient name and patient phone number will be stored here. Okay? And the appointment data will have only a reference, which is the patient data, to the data in this database. Now, if we decide to develop the system using the microservice architecture, we will have two services. Okay? The first one is or handles the appointment data only. Okay? And the second service handles the patient data only. So in this case, the client makes the first request for the appointment. After we get the response, based on the ID, we can make another request to the patient contact service to get the patient name and patient phone number. Maybe this can help. So this is the response for the monolithic service. As you can see, the patient name and patient phone number is already here. Okay? It's already in the response. We made one request, and we got one response that has all data. Okay? The situation here is different. Here, we make a request to the appointment. We just got the patient ID. If you can see here, we don't have the patient name or patient phone number. Why? Because the appointment microservice has only access to the appointment data. It does not have access to the master data of patients. Okay? Then, after the client gets the response, it can make another request to the patient master data or the patient contact service to get the phone number and the name. Okay? Let's go back. In this case, monolithic architecture, we just need to grant the user or the employee access to one service. And here is the major point. If a patient does not have appointment, can the employee or the client get the data of patient, such as the name and phone number? No. If the patient does not have any appointment, this service will return not found. Here, the patient contact service, it means contact information service, is decoupled from the appointment service. So how can this service knows if a patient has appointment or does not have appointment? Okay? They are decoupled. In this case, the problem is the client can make a list of patients' IDs and get their data from the patient contact service. And the patient contact service cannot know or identify if this patient really has appointment or does not have appointment. Okay? So this is the major problem of microservices. Because they are decoupled, the patient contact service cannot know if a specific patient has appointment, for example. By the way, the same idea can be applied to different cases, okay? Because all applications in the hospital will reference the patient master data. Now, yeah, one more question is, one might ask, okay, how can the client make a list of IDs and request their data, okay? Because the application, the hospital application, the appointment management system does not allow that, okay? That's easy. They can use a standalone HTTP client and make requests directly to the service without using the hospital software. If I know the URL or the endpoint of this service, I can make requests using any HTTP client, providing that I have a valid token, which is the case here because I am insider and I am authorized to access this microservice. Okay, the most vulnerable services are the services that expose master data. These are the most vulnerable services. And now let's move on to the countermeasures or to the security solutions to this problem. Okay, how can we prevent or mitigate this problem? How can we prevent, like, the employee from making or getting data of patients? Okay, so we have different solutions. We have like the weak microservices, API gateway, strong identifiers, the auditing, and the tokens. Well, the concept, I made this concept, weak microservices, because it is not fully microservice. It's a service, or let's say a microservice, but we can allow it to access the patient master data directly. Okay? And this is just exception for master data. So the service cannot access any transaction data except the appointment data, but we can allow it to access the patient master data just to avoid and to prevent the user from accessing the patient master data directly. So in this case, the response to this service will have all information the client needs. So the client will not need or does not need to make another request for the patient master data. Another solution is the API gateway. And as the name implies, API gateway is a gateway, okay, between the client and the microservices. Okay? And this gateway will be responsible for aggregating data from multiple microservices to serve a single request. So the client makes single request, then this API gateway can aggregate data from the appointment service and the patient contact service. In this case, the client should not be granted access to the microservices directly. They should have access to the API gateway only. Okay? In this case, yeah, we can solve the problem because if no appointment exists for a patient, then no data will be returned to the client. And the client cannot access the patient contact service directly. The third solution is the auditing. So yeah, the auditing could be simple, very simple, just logging of requests. So we know each employee, what's he doing, okay? Or it could be complex, as like deploying a software that identifies the abnormal behavior of users. Okay? Yeah, this is good. It makes the employees accountable for their actions. So if I know that my actions are audited, then I will not make any request that does not like benefit the business. Okay? But the problem, it needs resources. So we need teams that checks the auditing logs on a regular basis. Okay? If you don't have a dedicated people for that, then forget about it. You can't ask the programmer, for example, to check the logs every day or every week. Okay? He or she will check it once, twice, then he will forget about it. So we have, or we should have, a dedicated people for auditing who checks the logs and consolidate data from multiple logs. So each auditing entry could have information about when that happened, who made the request, what data was returned, and so on. Okay? So it could contain a lot of data about the request. The fifth solution or countermeasure is the strong identifiers. So this solution says, first of all, do not use protected data as or to reference business objects. What are the protected data? For example, the SSN, the phone number, the insurance number, and so on. We can't use these data to reference business objects in other applications. For example, in the database of appointments, we shouldn't use the SSN to say that this appointment is for this patient. Okay? And we also should not use predictable identifiers, such as sequential numbers, 1, 2, 3, 4, and so on. Okay? These are predictable, and I can expect, like, what are the IDs? For example, I can make a request for the patients with IDs from 1 to 10,000. Okay? Because they are sequential, it will be highly expected. What this solution says is we should use strong identifiers. What are the strong identifiers? There are random strings, like this one. It's composed of random characters, numbers. It could be case sensitive. Okay? So in this case, it will be difficult for the client or the employee to predict the IDs of patients. Okay? So this is safe from brute force attacks. So I can't create a list from 1 to 1,000. Yeah? But it's vulnerable to replay attacks. What does that mean? It means if I know the ID of a specific patient, then I can use it later on to get his data forever. For example, a patient has appointment today. I knew his ID. Okay? Then I can use this ID to make requests for the next year. And the last solution is the tokens. Okay? What are the tokens? They are secure or encrypted strings. And these strings will be composed, of the token will be composed of two parts: identifier, which is the patient ID, for example, okay, and the validity or expiry timestamp. So how it works: when the client makes a request to get the appointment service will fetch the appointment data from the database. Okay? But before returning the data to the client, it will encrypt the patient ID along with expiry timestamp. So the client here has a token that represents the patient. Okay? Then it can send this token to the patient contact service. The patient contact service can decrypt the patient ID. It validates if the expiry timestamp is still valid, okay, then it will return the patient contact data. So this solution will be safe from the brute force attacks and replay attacks, because I can't use the same token twice. If I use it twice after 5 minutes, 10 minutes, it will be invalid. Okay? And thank you so much. Any questions? Okay, thank you so much.